We've been looking at adding, subtracting, and multiplying polynomials. Today we're going to look at how you divide polynomials. The first example on your note sheet says Ariana needed 140x squared plus 60x squared inches of a paper to make a book jacket, 10x inches tall. In figuring the area she needed, she allowed for a front and back flap. If the spine of the book of the jacket is 2x inches and the front and back of the book of the jacket are 6x inches, how wide are the front and back flaps? Kind of a lot of information to take in. Luckily, we have this little diagram to kind of help us out with a lot of that information on there of what this book jacket looks like. The big thing we need to notice is they were talking about area. If you're looking at the area of a rectangle from last year, you know that is your length times your width. Okay. Now, if you're looking at the picture, they did tell us the width here is 10x. And we also know that the area of this whole thing up on the top is 140x squared plus 60x. So what we need to figure out is something with the length. Let's solve this little equation for the length. If we divide both sides by w, it tells us that the length is going to be equal to the area divided by the width. So let's try to figure out now what the length of this would be. So the length would be equal to the area, which is 140x squared plus 60x divided by the width of 10x. Okay. One of the things we're going to be looking at today is dividing polynomials like this. And you have a polynomial on the top here in our numerator and also one in the denominator. In the denominator, we call this a monomial because it's only one term. What you want to think of when you do this is basically it's kind of like a common denominator. So you want to think, what is the first term on the top divided by 10x? And also, what is the second term on the top divided by 10x? And if you divide or cancel out, just like we've done with some of the exponent properties, then you can figure out what this length is going to be. So doing some cancellation here, we know 10 goes into 140 14 times. X cancels out with x squared, leaving one x on the top. Similarly with this other one, 10 goes into 66 times. These x's cancel out, so it'd just be 14x plus 6. So what that is telling us is the distance all the way across this is going to be 14x plus 6. So this distance all the way across, 14x plus 6. Well, if you look at what they tell us also here, we know or can figure out a distance for just kind of the spine and the two main parts of the book there. If we add those together, 6x plus 2x plus another 6x, that adds up to 14x. The only two parts we're not sure on is how big these flaps should be. So let's do a little subtraction of polynomials now. If the whole thing is 14x plus 6 and this part is 14x, what do we get if we do a little subtraction there? Well, we get 14x plus 6 minus 14x. And if we subtract those, we get that there would be 6 inches remaining for these two flaps. And because we have two of them, we got two flaps equaling 6 inches. Dividing that out, dividing by 2, we see that each flap should be 3 inches. And that would be the solution on this one. So whenever you're doing some dividing, you want to, by monomial, divide each term by that monomial. Let's try some more of those. Some things to think about when you're dividing polynomials by a monomial: divide each term in the polynomial by the monomial, just like we talked about. All right, let's look at number 1. On number 1, they want us to divide these. So basically, each of these three, this one, and this one, need to get divided by 4x. Okay, so dividing the numbers, just divide like you normally do. So when we're dividing this first one here, 4 divided by 4, that's 1. You don't really need to write the 1 if you don't want to. We also have x cubed divided by x. Well, one of those x's was canceling, leaving an x squared. All right, divide the second term. 8 divided by 4, that's going to be 2. These x's would cancel when we're doing that one, leaving no variables in that term. The last one, it's a minus, so we don't think of that as negative 12 divided by 4 would be negative 3. X squared divided by x, there would be one x term left, and that would be your answer. Okay. Usually, like if this was a multiple choice test or something, you might see this written a different way. Usually they write it in descending order. So you might see it written as x squared minus 3x plus 2. You could also write it that way. Either one would be fine. Usually this is the one that we write. All right, let's try another one. Number 2. Now they want us to divide three other termed polynomial by another monomial on the bottom. So do the same thing. Okay, we got 16 divided by 8. That would be 2. A to the 5th divided by A to the 4th. That's going to be a single A. B cubed divided by B cubed. Those would cancel out when we're dividing those first ones. So this first term won't have any B's with it. All right, let's go to the next one. 12 divided by 8. Now we hit something kind of new here. 8 doesn't totally go divide into 12. So what you want to look at is there any other numbers that would simplify? We do have a number. 4 is a number that goes into both. So we know 4 goes into 8 2 times, and 4 goes into here 3 times. So we're going to write this one as 3 over 2. Now we want to keep dividing. Next one, we got 4 A's on bottom, 3's on top. Well, we would want to subtract there. Anytime you're dividing polynomials, subtract the exponents. All 3 of these would cancel out. There would be 1 left here. 4 minus 3 is 1. So we have 1A left on the bottom. If we subtract the B, same thing, we're left with 1, but this B would be left on top because there's more on bottom than there is on top. All right, so we've subtracted 2 of the 3. Let's do the last one now. Okay, if we divide this last one, 8 again doesn't go into 20, but we have our number 4 that goes in there twice here, 5 times here. So this last one's going to be minus 5 over 2. Okay, we got 1A on top, 4 on bottom. If we subtract, there's going to be 3 left on bottom. So A cubed. And if we subtract our B's, there's going to be 2 left on top. So that would be the answer for number 2. All right, for tomorrow, I want you guys to try out number 3. See if you can divide those 2 polynomials for tomorrow. All right, now let's look at a different type of dividing. In this situation, now we're not dividing by a monomial anymore. We're dividing by what's called a binomial, because this polynomial has 2 terms, not 1. When you start dealing with 2 terms, now that division we just did in the last one doesn't work. So what we're going to do is what's called long division today, and see how you can divide these 2 monomials with long division. Now, you've heard the term long division before back in kind of elementary school when you learn to do division. It's very similar to that. You're going to put what you're dividing, so 2x cubed plus 5x squared minus 2x minus 15. And then that goes on the inside of your division bar. On the outside is what you're dividing by, 2x minus 3. Now we're going to divide that out. So what you're going to do first is take this first part right here, 2x, and see what do you get when you take the first term inside divided by the first term outside here. So what do we get when we take 2x cubed divided by 2x? Well, the 2's would cancel, and we'd be left with x squared after we simplified the x's. Whatever that divides by, that goes on your top here. So we're going to put x squared there. Now what you do is you multiply whatever's here, and this is the same thing you did in long division, multiply by what's ever here back into the 2 things here. We're going to multiply those back through. All right, so if we do that, what we end up with is 2x cubed. And these 2 you should always notice are going to be kind of the same here if you've done it right. And then you also have to multiply x squared times negative 3, which would leave negative 3x squared. All right, now if you think back to long division, the next thing you would do is you'd subtract to see what's going to be left over, and that's what we're going to do here. Now when you subtract, okay, you're going to be subtracting all of this. These ones are always going to cancel out if you've done it right. But what we're going to be doing is taking 5x squared minus a negative. So anytime you're minusing a negative, you got to think plus. 5x squared, this is going to end up being plus 3x squared, which would be 8x squared. We're minusing a negative. Okay, bring down your next term. And now the process starts over again. So we're going to do the same thing we just did, kind of again. We've got back to the beginning. So now we need to start back up top here. We're going to take the first term here divided by the first term here. So what do we get when we take 8x squared divided by 2x? Well, 8 divided by 2 would leave us 4. If we simplify x squared over x, we'd have 1 x left. So that's the next term in our quotient. Now, what we did is multiply these back through. So that's what we need to do again, multiply these back through. And again, if you do this right, you should always see this next one match up. 8x squared if we distribute 4x times 2x. Multiply the other one, you get minus 12x squared. Okay, now we're going to subtract. So anytime you subtract, these will always cancel out, and you're going to subtract what's left. Negative 2x minus a negative 12x, because we got minus a negative here. Negative 2x plus 12x, that's going to end up being, whoops, sorry, didn't mean to put that squared on there, is going to be negative 2x plus 12x would be 10x. Okay, drop down the last number. Finally, we got to do this one more time. Okay, process starts over again. So divide 10x by our 2x here again. So 10x divided by 2x, that's going to leave us with 5. That's the next term in our quotient. Distribute that back through. So now you're going to take 5 times both of those. And if you multiply 5 back by both of those, you get 10x minus 15. We want to subtract that. These will always cancel out. And what we're left with is negative 15 minus negative 15. Negative 15 minus negative 15 is like negative 15 plus 15. There's nothing left over. That last number, that is your remainder. And if you end up getting a 0, that means there is no remainder in this one. So if we divide these two polynomials right here, the answer is what is right here. So the answer would be, for number 4, x squared plus 4x plus 5. All right, let's try one more here. Let's get number 5. Number 5, they want us to do kind of the same thing here. Divide through and see what we get on this one. So what are we going to get on number 5? Write it out. Okay, what you're dividing by goes on the outside. What you're dividing is on the inside. Okay, start out, divide the first things here and see what you get. What are we going to get if we take 2x cubed over x? Well, canceling 1x, you end up with 2x squared. That goes on top. Multiply through now. You're going to distribute this to both things. And if you distribute, you're going to get 2x cubed. Those should always match up again, plus 8x squared. All right. Now, if you subtract, we're going to run into a problem on this one. Notice, these should be fine. These would cancel out when we subtract. Do these match up, though? We got x squared, and then this term's just x. No. So this brings up a point that we're going to look at some more with some other one of these examples. But anytime you're doing these, you want to always check first, do you have every power of x listed? Our biggest power here is x to the third. So when we're doing these, we want to have every power of x accounted for all the way down to a constant term. And this one does not have an x squared term listed, does it? So if we try doing this, and we're going to look at another way tomorrow, you're not going to be able to divide this out. So when you're doing these problems, anytime there's a missing power of x, you got to actually write that into your problem. And if it's missing, just put a 0 in front of it. So this one would be like plus 0x squared plus 6x plus 152. All right, we'll keep looking at this one tomorrow and then how to finish that one. But that kind of gives you an idea of what we're going to be looking at.